This is Mr. Beck Does Your Homework, AP Physics, Homework 7.2, questions 10 and 11. A rock weighs 110 newtons in air and has a volume of 0.00371 cubic meters. So here's my rock. I know that the mg on it, the force of gravity on it, is the weight is 110 newtons. What is its apparent weight when submerged in water? So this is in air. Well, what's different when it's in water? When it's in water, I have a gravitational force and I've also got a buoyant force. So the apparent weight is going to be the difference between these two. How heavy it feels, well, if water's pulling up, it's how much extra I have to pull up to balance it out. So it's going to be the difference between the old gravity and the little bit of buoyant force. So the apparent weight is going to equal the force of gravity minus that buoyant force, because this is helping you out. So I've got a force of gravity already is 110 newtons, but my buoyant force is going to be the density of water times the volume of water displaced times the acceleration of gravity, rho vg. So this is going to be 110 minus the density of water is 1,000. The volume of this rock, they tell me, is 0.00371 meters cubed. That's good. So that's 0.00371. And gravity is 9.8. So this will give me the apparent weight of the rock because it'll feel lighter because the buoyant force is helping me out. If it is submerged in a liquid with a density exactly 1.7 times that of the water, what will be its new apparent weight? So now it's got an apparent weight there, and now we're going to do the same sort of thing, but I'm going to have a different density. So now my apparent weight is still going to be 110, but it's going to be minus a new buoyant force. So it's 1.7 times that of water, so that's 1.7 times my 1,000, that's my rho. My v is still 0.00371, and my g is 9.8. So that will give me my new apparent weight when it's submerged in a heavier liquid, a more dense liquid. So this is a bigger number, so subtracting a bigger number from 110 should make it even lighter than it was before.